So for this last section of chapter 3, we're going to be talking about the graphs of these polynomial functions. We're not going to actually be graphing anything by ourselves. Like we're not going to be making XY charts and plugging in points and then graphing them. This is more just being able to look at an equation of a polynomial and kind of look at some of the characteristics that it has with like what's the leading coefficient, what's its leading exponent, so that we can kind of talk about how would the graph behave if I was looking at it, if I had to graph it. Okay, and a lot of times like when you're doing some of these, if you have a graphing calculator, looking at the graph is also just going to either like confirm what you put down, or it's just going to kind of help aid you in like what that graph is going to look like. Like I said, we are not actually going to be graphing these functions. We're just going to be talking about what the graph would do. So when you look at an equation or a function that they give you, so that would be all of those things that we've seen so far since we've started this second half of chapter 3. So solving all those polynomial equations where you had like x to the fourth, x to the third, x squared, and all that stuff. We're just going to look at an equation, and we're going to look at two pretty main things about it in order for us to see what it's going to do. And we're mainly focused on the graph's end behavior. So end behavior would be eventually your graph is going to move in a specific direction. It's either going to go up or it's going to go down over time. And so we're trying to figure out what is it going to do based on what its polynomial equation looks like. So end behavior is kind of that thing I was just talking about, is the behavior of the graph, which remember all graphs have like x coordinates and y coordinates if you're looking at points. So we're looking at what's happening along the y-axis, and they refer to that as f of x, because a lot of times they have their functions written f of x equals, and remember I said in the past f of x is just a really fancy way of saying y. Okay, so we're talking about what is the y doing as your x values approach either positive or negative infinity. Because if you think about x's on your coordinate plane, they're the ones that go left to right. So if you're going to the right, so for you guys that would be this way, that's positive. Okay, 1, 2, 3, 4, 5, all the way to the right. If I'm going to the left, I'm going to the negatives. -1, -2, -3, -4, and so on. So they want to see, like, what is your x doing as it goes left or right? What's the end of the graph doing? What's the y doing? Is it increasing or is it decreasing? So we look at two things here. We look at the lead coefficient. So that's the number that's in front of that term with the biggest exponent. And then we look at the degree of the polynomial. So is it, like the degree would be that exponent, and we're mainly checking, is it even? Is it an even number? Is it a 2, a 4, a 6, an 8? Or is it an odd number? So is it just x, because I would have a 1, or 3, or 5? This chart that I have here for you guys kind of summarizes what's happening. I want you guys to look at just the left side for a minute. This is talking about if your degree is even. So that would be if it said x squared plus a whole bunch of other stuff, or x to the fourth, or x to the sixth. If that was the biggest exponent, your degree there would be even because you have an even number. So you're having an x squared, x to the fourth, x to the sixth, something like that. If the leading coefficient is positive, so that means if that first term has a positive number sitting in front of it, okay, then your graph is going to look like this. This is the end behavior of that graph. As x goes both directions, positive, negative, y goes positive. So they show you an example of a quadratic here. And we kind of talked about quadratics back in chapter 2 when they like opened up, opened down. We looked at that leading coefficient, that number in front of x squared, to see if it was going to open up or open down. If it was positive, it opened up. Down below here, it says that if it's negative, the end behavior changes a little bit, because now look at my graph, it opens down. And it's going this way instead. For my odd degrees, so over here on the right side of the chart. So this would be if you had just x, or if you had x to the third, or x to the fifth, or x to the seventh. It changes a little bit. Notice how the graphs, like they each, on either side, they go in opposite directions. Like one's always going up, one's always going down. That's because they have an odd number of solutions. So they're going to, like the graph is going to switch directions an odd number of times and go through that x-axis. They're just showing you a cubic function here. where you just had something x to the third power. If the leading coefficient is positive, this talks about like what the end behavior is going to look like. So it kind of describes what your x and your y's are doing. And then they also show you what happens when it's negative. Okay, so as we get started with these problems, you're going to want to use kind of these examples to help lead your way. Now, I'm not asking for specific numbers. I don't want to know what coordinates are that are on this graph. What you're going to fill out is something exactly like what I have circled in red here. So for all of these, you're going to be saying x is going to positive infinity and x is going to negative infinity because the graph is going to the left or it's going to the right for your x values. What changes is what happens to the y values. And so that's when you're going to want to use these like circled pieces to kind of help you here. So let me show you what I mean. Let's take a look at this first one. X to the 6th minus 7x to the 5th plus x to the 3rd minus 2. All you need to do is look at the very first term. Okay, x to the 6th. So the exponent is 6. That would be its degree. Which is an even number. 6 is even. Okay, the leading coefficient, I'm going to abbreviate that with LC. What number's in front of x to the 6th power there? 1. Okay, and it's positive. Okay, so here's your two key pieces. I need to look up above at my tables where it said that my degree is even, my leading coefficient is positive, because that's going to tell me what the end behavior is. So I'm going to come back up here for a second. Okay, we said even for my degree, positive for my leading coefficient, so it's going to be this one right here that I'm circling yellow. All you have to do is copy that down. Okay, so down here, and they write it kind of with the y first. I usually like to put x first. That's just a personal preference. So I like to put that my x goes first. So I'm going to say x approaches positive infinity and x approaches negative infinity. Because your x's are always going to do that. One's going to go to the right, which is positive, and the other side is going to go to the left, which is negative. Then we talk about what the f of x or what the y is doing. Okay, so up above on that chart, when x was going to positive infinity, so was y. Okay, and then as x is going to the negative infinity, y does too, because they go the same direction. So they're both going up eventually. Okay, so I know most of you don't have graphing calculators, but I'm going to graph it on mine real quick and just do a sketch of the graph so you guys can kind of see what this looks like. This is not something that you guys have to do. I just want you guys to understand like why they're saying this. So it's the graph is doing something like this. Okay? That's just a really rough sketch of what my calculator is showing me. But notice how on here, x going to positive infinity would be if I started at 0, 0, and I went to the right. That's x going positive. Look at what my y is doing. My y is going up, okay, which is also positive. Now, if I go to the other side, so if I go to the left, that's x going negative, but my y is also still going positive. So that's what they're talking about when they say end behavior. End behavior is as the graphs, because like mine, at this point, they just shoot straight up on my calculator. Probably because the numbers are getting really, really big at this point, because you've got x to the 6th power. So if I put in like a 6, that's going to be a large number, 6 to the 6th power. Okay, so it's going to eventually taper off where it's either going to go straight up or straight down, or they're going to go in opposite directions. But that's just a kind of a rough idea of what's happening. So let's take a look at number 2, and then I'll get you guys some to try on your own. So this one, you've got negative 3x to the fourth plus 2x minus 1. Look at that first term. What's the degree of this term? Good, 4. Is that even or odd? 4 is odd. Even. What's the leading coefficient? Negative 3. Is that positive or negative? Okay, so again, I'm always going to have x going to positive infinity, and x is always going to go to negative infinity. What we need to fill out is what my y is going to do. Okay, so I'm looking at the same kind of left side of that table. So up here, I'm looking now at this one down below. Because this is even, my degree is negative. So I'm using this one that I kind of circled up in purple. So if I look at the picture of the graph, they're both going down over time. So both of my y's for this one are going to go to negative infinity. Do you guys understand where I'm getting that from your charts up above? Because I want you guys to try it now. So if you guys turn the page over, there's 2 more examples. I'm going to give you guys some time. I want you to fill them both out. So can you guys tell me for number 3, based off of your first term, what the degree is? So that's odd. What's the leading coefficient? Positive 4, so positive. Okay, so as x goes to positive infinity, what does the y do? You're at positive or negative infinity? You got a 50-50 chance of being right, even if you guess, so just guess one if you don't know. As x is going to positive, f of x is going to Good. So then as x is going to negative, f of x is going to, what do you think? Good, negative. Okay, for number 4, looking at that leading term, what's the degree when it's just x? 1. Okay, all letters by themselves technically have an exponent of 1. We just don't write them, because if we did that for all of them, every single time you guys ever saw an x before now, they would all have little tiny 1s, and it would be annoying because they'd be everywhere. Okay, so that's odd. The leading coefficient, is it positive or negative? Negative, because it's negative 1/2. All right, so for this one, as x goes to positive infinity, where's your y going? To negative infinity. So because it's odd, they have to go in opposite directions. So since this one went to negative, the other one has to go to positive infinity, because they have different, when it's an odd function, eventually, like, odd means that that's the number of times it crosses your x-axis, an odd number. So the most that this can cross is 1 time. So at the x is kind of where it switches. So at one point it's going to go up, and at the other point it's going to go down.